For my Rail-fence cipher, I thought it was really cool because we're actually not changing any of the letters that they're mapped to. So A is going to still equal A. But this one is just repositioning where the letters are. So you have the full message there, and we just have a specific way we're going to reformat the numbers. So for instance, if I show this is a test, if there's only one rail, so this takes in rails, and that means how many rows that there will be. So in this case, there's only one row, and so it only encodes to, this is a test. However, if we add one, now we have 2 rows, and it goes in a zigzag pattern. So THIS space, that's why it doesn't look like there's a spot here. I persisted spaces. IS space A space TEST. Then what you do is you take the top row, and that becomes your first half, in this case because there's only 2 rails, and then your bottom. So it'd be TI space SATS, which we have up to there, and then we have HSI space ET. If I go 3 rails, it's the same idea. We have zigzags going up and down. And if I want to decode a message, I can just click decode, and it will go up here. So it's clearly not the 1 rail. It's not 2. It's not 3 in this case. It's 4. So the HTML looks basically the same thing as the rest of the ciphers I've been doing. So we have our plain text. We have our middle section right here. We have the input for the rails. It needs to at least have 1, so we auto set that. When it changes, then we update the rails. We have the intermediate step of the zigzag that we show. And then we have the encode and decode buttons. And lastly, the ciphertext output or input. Here is the source that I got this information from. We automatically have a 2D array that is empty. We have rails that I have just set to 1, and we're automatically going to encode. So to display, we're going to clear out the Rail-fence table. We're going to cycle through the Rail-fence array. And we're going to go through each of the positions in the internal array. Well, we're going to go through, so we have an array of arrays. So we have an array of all the different rows that we have in there. And we're going to cycle through all of them. We want to have a max amount of columns that we display to be 27. Or it'd be 28 columns, index 0 through 27. And what we're doing is we've now populated this Rail-fence array to look like, well, at the point that we're showing this, we've populated it to look like how it looks in the table. So let's say we have 3 rails. We're going to have 3 internal arrays. And as we cycle through each one of them, we're going to make the top row. And then we're going to make the middle row and then the bottom. And for each one of those, we're then going to show what element is in that position. So it's pretty simple with what we're showing there. To encode the text gets a bit tricky. So we automatically set the row index to 0. And we tell it that it is increasing. And by increasing, that means it's going to be going down and then up. So this is an increasing direction, and this is a decreasing. And the reason I say increasing because it actually increases the index of that row. So this would be index 0, index 1, 2, and 3. And this would be decreasing. So we automatically set it to increase. We then make it uppercase, the plain text. We grab that value. And for the text, we're going to cycle through as long as the text length, as long as I is less than the text length modulo 2 times the rails minus 1. This is going to add padding to our cipher text, or to our plain text. So this actually needs to be equal to a multiple of 2 times the number of rails minus 1. And this really is going to be apparent when we get to decoding. So basically we're just making it a little bit longer by adding some spaces to it. For each letter in the text, we're going to encode it and tell it what row index it's going to be added to. If the rail is greater than 1 and it's increasing, then we're going to increase the row index. Otherwise, we're going to decrease it, and that's going to give us that zigzag look in our array. If row index equals the amount of rails, then it's no longer increasing, and we're now going to decrease it by 2 because we've already increased it by 1, and it would need to be decreased by 1 at that point, so we just decrease it by 2. So this is the idea that we've hit that bottom peak, and we now need to go back up. And this is the same idea, except we've hit the top peak and we need to go back down. We then display the Rail-fence table. We clear out the ciphertext. We have a temporary ciphertext result, and we go through each row of the Rail-fence array, join that whole inner array together, and add it to the ciphertext result. We then trim off the extra spaces at the end and put it in the ciphertext. To encode a letter, we take the character and the specific row index, and for the Rail-fence array, for each element in there, we will get the int from the index, and if it equals the specified row that we've given, then we will push that character into that rows array. Otherwise, we will just push an empty string. This will still give it an element, but it'll be empty. To decode, we clear out the ciphertext. Well, we set it to uppercase. Then we clear. Then we put it in our value of text. We clear out the plain text. If rails equals 1, then we just will return the ciphertext and show the interim step. Otherwise, we will again pad it, and this is really important for the decoding. So we want to make sure that it is a multiple of that 2 times the rails minus 1. K is going to be the length, or the text length, divided by 2 times rails minus 1, which is why we really need the text length to be a multiple of that. So once we have K, we have a column index of 0. We cycle through the Rail-fence array, if the rail index equals 0, then the rail fence array at 0 equals the text substring of the column index k, and we split it. So what we're trying to do here is determine where we need to actually make the splits. In this case, we have 4 at the top, we have 4 at the bottom when we've added the padding. All of these interim rows are going to have k times 2, so it'll be 4 times 2, and that'll be 8, and we can prove that. 1, 2, 3, 4, 5, 6, 7, and we actually come up 8. And here 1, 2, 3, 4, 5, 6, 7, 8. So we've added padding to finish this off. So as I go through the rail fence array, so if it's either the top or the bottom, we know that that is going to be the size of k, which will be the beginning and the end of our ciphertext. Then we have the middle rows, and we know they're going to be 2k. And so we're getting the substring of where our column index is, and it'll be the length of the substring will be 2 times k. And then we're just going to split it on the letter. And then we increase the column index by that amount. Then I have it normalize the decode rows. And so in this rail fence array, what I'm going to do is I'm going to go and increase the empty cells so that we have that now expanded zigzag pattern. Otherwise, we would have all of the elements of the top row in the first few columns, and then in the second, and it would just look all squished together. So we want to expand it out to actually make that zigzag visible to the human. And that's what this is doing here. So for the top and the bottom row, we're making sure that we expand it. And then this is the code for the middle rows. We then want to display the fence table and then concat the plain text. So concatenating the plain text, we're going to go through that zigzag, where before we were taking the top row and the second row and the third row and the fourth row. We now need to go by column and by row. So we now need to, instead of taking this just top row and adding it, we need to go column by column. So in this one would be S and then U and then B, but we're changing the row as we go. So we're changing row and column as we go to regain our plain text. We have our update rails function. So we reset the rail fence array to be empty. And for however many rails there are, we add an empty array nested in our main array. We display the rail fence table, and then we encode and decode. And this is similar to what we had before. Anytime we update anything, we call this encode decode. So if we're encoding, we call the encode text. If we're not, then we're decoding. We set the encode value, call the encode decode, and then on our initial load, we call display rail fence table. I'd like you guys to play around with it and like and subscribe.